What's up, everyone? Welcome back to my channel. My name is Xavier, and I'm currently working as an IT specialist. In today's video, we're building part 2 of our network engineering home lab using Cisco Packet Tracer. If you watch part 1, which is you definitely should, has a lot of information in there. We built a basic LAN with VLANs, Inter-VLAN routing, DHCP, NAT, and ACLs. Now we're looking to build upon that knowledge with this upcoming lab. In this video, we're building a small enterprise style network with layer 3 switching, OSPF dynamic routing, WAN simulation, SSH routing access, port security, Syslog mounting, and so on. So let's get into it. Here's the topology we're building. We have 2 Cisco routers, 1 layer 3 switch acting as our core, 1 access switch, multiple PCs, and 1 server for logging. A quick breakdown. The layer 3 switch is the brain of the internal network. It routes traffic between VLANs and acts as the default gateway for users. The access switch connects end devices like PCs. Think of it as a level floor's level, which is an office building. Router 1 connects our internal network to our simulated WAN link. Router 2 represents a remote branch office, so that we're building essentially a small company with a headquarters or remote site. I just want to thank you so much for clicking on the video and watching them. It really does give me the drive to keep going, and I want to thank you so much. So first, we need to enable routing on layer 3 switch. By default, a switch only a switch traffic is layer 2. That means it forwards frames based on the MAC address. But we want a layer 3 function. You have to enter a global configuration mode and type IP routing. This command turns the switch into a multi-layer device capable of routing IP traffic. Then we're going to create our VLANs. Each VLAN represents a separate broadcast domain in real life. These would separate departments for performance and security reasons. Next, we create our SVI interfaces. An SVI interface, switch virtual interface, is a virtual layer 3 interface tied to a VLAN. This interface becomes the default gateway for the devices in that VLAN. We have to repeat this for VLAN 20 and VLAN 30 using the respective subnets. Once this is done, the switch can route traffic between VLAN 10, 20, and 30 internally without needing a router. This is the power of layer 3 switching. Now, let's configure the trunk between the core switch and the access switch. Why do we need a trunk? Because multiple VLANs need to travel across a single physical layer. A trunk port frames with VLAN ID, so the receiving switch knows which VLAN is going to be tagged. As you can see, we did get an error. When we did try to trunk the port, we have to input switch port trunk escalation dot 1Q, and then we can switch port mode trunk. Once we get done with that, then we can move on to the access switch. Now that the trunk can carry multiple VLANs, we can configure access port for the end devices. While on the access switch, we need to go ahead and assign each VLAN a port. And as we work on that, all this is in within my GitHub. All the details that I put into this, all the IP addresses. This is, and also a step by step if you want to download that or copy that over, so you can go along with me, or you can do it on your own. I did try to make it as simple as possible, so that way anybody can repeat these steps and learn something. But now, okay, so now we want to test connectivity. So from a PC in VLAN 10, I want to try to ping a PC in VLAN 20. If it works, that means the VLANs are created correctly, the SVRs are up, and the internal VLAN routing is functioning. If it doesn't work, it usually means to check your IP addresses, your default gateway, or if your trunk configuration. Now we're connecting router 1 to the core switch. For this, we have to put no switch port. The no switch port command converts the interface from a layer 2 to a layer 3. And we're also using a /30 subnet. A /30 subnet gives you exactly 2 usable IP addresses, perfect for point-to-point links. So we move on to the router now. We have to configure port G0-1 or port 1 on the router. Again, during this time, you can pause it if you need to, if you are following along with the video. I um it it does get a little confusing sometime with how many zeros and numbers you'll be typing. You always want to make sure that you are double checking your work, as I am, and I have made a few mistakes. But now we configure OSPF. OSPF stands for Open Shortest Path First. It's a dynamic routing protocol. Instead of manually creating static routes, uh, routers automatically share network information. So first, we're going to go to the core switch, and we want to input route OSPF1, and then we don't put network, and the network that we want to put the IP address, the first 2 octets of the IP address, and then the subnet mask, including area 0. The 1 is just the process ID can be any number locally. And the network statement tells OSPF which interface should participate. Area 0 is the backbone area, acts as the core for exchanging router information between different areas. Sorry about that, I couldn't network. There we go. So now we're going to move to router 1 and do the same thing. Router OSPF1, then the network. See, as I was saying, so many zeros in there. You really got to make sure you pay attention to that. Oh, I'll put an extra dot in there. There we go. The next network. Don't discourage when it does do that. When it kind of jumps like that, you can press enter to go to the next line, or you continue typing the command. It still works. Now we're going to go to router 2. And again, we're going to do both interfaces, the one facing the other router and also the one facing our server. Once it is configured, routers from neighbor relationship and exchange routes. Yeah, so it's easy to just press enter and just keep going like that, because it kind of messed me up a little bit there when it jumped. So we got area 0, and there we go. Now we need to check. So there's 2 commands: show IP OSPF neighbor. The primary purpose of the command is to observe the neighbor data structure and verify the structure have successfully become neighbors and reached a full state. OSPF neighbor. There we go. See, full state. Next is IP route. It shows the specific path of a packet will take to reach the destination. You'll now see an O, meaning the OSPF learn them dynamically. Next, let's secure remote access. By default, many devices use Telnet, which sends password in a clear text that's insecure. We're going to do it through SSH, which is encrypted traffic. On the core switch, you create your switch name. Then you put IP domain name. You can put the domain name. Then I put lab.local. Then I want to encrypt crypto key generate RSA. The RSA key are required for SSH encryption. And then I just picked 512 just for the sake of this lab. Usually you want to go higher, but it takes a little longer for it to generate that key. Then you want to create your local user, and you want to create your secret password. The secret keyword encrypts the password, and then configure VTY lines. We're going to do line 0 through 4. This forces SSH only and use the local username database. Now we're going to go to a PC. Open the command prompt and type ssh-l admin, then the IP address of the default gateway. Type in the password. And now we securely manage the switch remotely. Now let's protect the access layer. Without port security, anyone can unplug a company PC and connect their own PC. On the access switch, we have to define which interface. Then we have to go switch port mode access. And then with a identify the VLAN. Then port security. Spelled that wrong. Port dash security. Maximum 1 means only one MAC address is allowed. Then violation shutdown. Sticky means switch learns the MAC address automatically and saves it. If another device plugs in, the port goes into an error disable state. Then to check this, show port security interface, the certain interface, as you can see, it has been enabled. Monitoring is a critical real life environment. Assigning, let's go ahead and assign. I've already assigned the server and IP address, and now we need to go to the layer 3 switch and input logging and the IP address of the switch of the server, and now it is now logging. Now let's go ahead and try to trigger some logs by turning on and off interfaces. You turn off an interface, you type interface and the port that you want to turn off, and you type shut down. Those aren't the logs. That is something else. Syslogs. Okay, it didn't populate just yet. Let's try this again. Everything is down. No shut is going to bring everything back up. Let's go back to the logs. Okay, let's try to go back into it. And as you see, logs has popped up for me turning down the port and turning up the port. Let's try one more time just to make sure. And there we go. And now that's it. Now you've now built a multi-VLAN enterprise LAN, layer 3 switching, OSPF dynamic routing, WAN simulation, SSH routing management, port security, and centralized logging. This lab is structured like a real small business network. Thank you guys so much for sticking around during this time. If you truly understand what we configured today, not just commands, but the logic behind them, I think that we did do that today. We did discuss a few things on the background of why certain commands did certain things. And I do want to definitely thank you so much for watching this video, and peace. Have a good day.